there does not exist a least positive real number. Here we will prove a theorem first, and then we will move on to some problems which can be done using order properties of real numbers. Okay, so the first theorem is this: if AB greater than 0, then either A greater than 0 and B greater than 0, or A less than 0 and B less than 0. You know this result. If the product of two real numbers is positive, then either both of them must be positive or both of them must be negative. So how can we prove this? Here we are given that product of A and B is greater than 0. So one thing is sure, here A not equal to 0 and B not equal to 0. Why? Because if either A or B is equal to 0, then AB is equal to 0. Here AB is strictly positive, so both of them are non-zero. Now I am considering A. We know that A is a real number and now A not equal to 0. Then by trichotomy property we can say that A has two chances. What are they? Either A greater than 0 or A less than 0. Suppose A is greater than 0, then its reciprocal 1 by A is also greater than 0. Here we are given that AB is greater than 0. So actually you have 1 by A is in P and AB is in P. Then by the definition of P, their product must be in P. So this implies 1 by A into AB is in P, means it is greater than 0. 1 by A into AB means you can apply associative property. So we will get 1 by A into B greater than 0, that is B greater than 0. So if A is greater than 0, then B is greater than 0. So either this happens. Now if A is less than 0, then 1 by A is also less than 0, or minus 1 by A is greater than 0. Okay. Then minus 1 by A into AB must be greater than 0, because product of two positive numbers is again positive. And this implies B minus B greater than 0. If minus B greater than 0, then B is less than 0. So if A greater than 0, then B is also greater than 0. If A less than 0, then B is also less than 0. Hence the theorem. Now there is a corollary to this theorem. Corollary means a result which follows immediately from a theorem. So if AB less than 0, then either A greater than 0 and B less than 0, or A less than 0 and B greater than 0. If the product of two real numbers is negative, then one of them must be positive and the other must be negative. Okay. How can we prove this corollary? Just like we proved the previous theorem. So this is a homework for you. Try to write down the proof alone. Okay. Now I will be moving on to some problems. Here I am going to determine some sets. So the first question is, determine the set A equal to set of all x element of R where 2x plus 3 less than or equal to 6. So how can we do this? I am taking an x from A. X is in A means 2x plus 3 is less than or equal to 6, and this is an implies and implied by condition. Now I will add minus 3 on both sides. So I will get 2x less than or equal to 3. Now I will multiply both sides with the 1 by 2, and 1 by 2 is positive. If we multiply an inequality with a positive number, then there is no change for the inequality. So this implies and implied by x less than or equal to 3 by 2. Okay, so what to say? I can say that A is equal to set of all x element of R where x less than or equal to 3 by 2. This is our A. Or actually this is interval minus infinity 3 by 2. 3 by 2 is in the set. Now the second problem. Determine the set, I will call this B, set of all x in R where x square plus x is greater than 2. So we have to determine what all real numbers are there in the set B. So let x be an element of B. This implies and implied by x square plus x is greater than 2. Add minus 2 on both sides. We will get x square plus x minus 2 greater than 2 minus 2, which is 0. And this implies and implied by x square plus x minus 2 can be written as x plus 2 into x minus 1. This is greater than 0. So product of two numbers is greater than 0, positive. This implies and implied by either both the numbers are positive. So either x plus 2 greater than 0 and x minus 1 greater than 0, or both are negative, x plus 2 less than 0 and x minus 1 less than 0. Okay. So this implies and implied by either, here I have x plus 2 greater than 0. X plus 2 greater than 0, add minus 2 on both sides, we will get x is greater than minus 2. So either x is greater than minus 2, and here I have x minus 1 greater than 0, add plus 1. So x greater than 1. Or x less than minus 2 and x less than 1. So 0, 1, minus 2. This is our real line. The first chance is that x is greater than minus 2, x is greater than minus 2, and x is greater than 1, x is greater than 1, and here I have and. So both should happen at the same time. X must be greater than minus 2 and x must be greater than 1. When will this happen? So this implies and implied by either x greater than 1. If x is greater than 1, then x is greater than minus 2 also. Or now the second one, x less than minus 2. X is here, x must be less than minus 2 and x must be less than 1. Both should happen at the same time, and both happens when x is less than minus 2. So or x less than minus 2. Okay, so this means either x is greater than 1 means x element of 1 infinity, or x must be in minus infinity minus 2. X less than minus 2 means this. So what is your B? Our B is minus infinity minus 2. Here I have OR means union 1 infinity. This is our B. Now the next one, the third problem. Determine the set C is equal to set of all real numbers which satisfies 2x plus 1 divided by x plus 2 less than 1. So just assume that x is in C. So this implies and implied by 2x plus 1 by x plus 2 is less than 1. Add minus 1 on both sides. So we will get 2x plus 1 by x plus 2 minus 1 is less than 0. This implies and implied by 2x plus 1 minus of x plus 2 divided by x plus 2 is less than 0. And this implies and implied by 2x minus x is x, 1 minus 2 is minus 1 by x plus 2 is negative. Again I can write x minus 1 by x plus 2 as x minus 1 into 1 by x plus 2 is negative. If the product of two numbers is negative, one of them must be positive and the other must be negative. Here 1 by x plus 2 is positive means x plus 2 is positive. 1 by x plus 2 is negative means x plus 2 is negative. So this implies and implied by, as in the previous problem, we will have two cases. Either x minus 1 greater than 0 and x plus 2 less than 0, or in the reverse order, x minus 1 less than 0 and x plus 2 greater than 0. That means either x is greater than 1 and x is less than minus 2, or x is less than 1 and x is greater than minus 2. So let's check. This is a real line. 0 is here, 1 is here, minus 2 is here. The first case, x greater than 1. So x is greater than 1 and x is less than minus 2. X is less than minus 2. These two regions are disjoint. X is greater than 1 and x is less than minus 2 cannot happen simultaneously. So there is no x satisfying the first condition. No such x exists. Now the second one, x is less than 1. X is less than 1 and x is greater than minus 2. X is greater than minus 2. Both of them happens at the same time if x lies between minus 2 and 1. Okay. So this implies and implied by x element of minus 2, 1. The first part, there is no x satisfying the first inequality, first two inequalities, and x satisfy the second inequality if x is an element of minus 2, 1. So our C is interval minus 2, 1. Okay. Now we will prove some more important results in our next session using order property so far. So till now, stay Study well. All the best.